I hope everybody is already here. So we'll be starting now with the session. So I will be sharing my screen and start talking about it. Just confirm once if the screen is visible and I'm completely audible to you. All right. Can somebody confirm if my screen is visible? Just type it in the chat box. It's fine. The screen is not visible to you? Okay. Now is the screen visible? Okay, great then. Thank you. Thank you so much for the confirmation. Okay, so hello and welcome all. My name is Christina Burwa and I'm a technical member of Geeks for Geeks LPU. So today we'll be discussing about introduction to linked list. So since we know that linked list is a very important concept in data structures and algorithms, so we'll be talking about it. So let's get started with the definition part first. So what it says is that a linked list is a linear data structure in which the elements are not stored in contiguous memory location, rather are stored in the memory location which are free. What this means is that, like, unlike array, in linked list, the data are scattered. The data that you're storing are not going to be stored one after the another in a row or in a sequence. Okay, instead what's going to happen is that it's going to be scattered, right? Because you just know the address of the location where your data or your value is being stored. So that is the only point you can refer to, right? So that's the point. Now, as you can see in the image here, in the first image, it's let me take the pen. Yeah, great. So as you can see, first number that we have is 345, right? Then it is pointing to 358. You must be wondering that the next thing that has to come should be maybe 346, right? But it isn't that. It is pointing to some other location, like completely different from what we were doing in the arrays. So that's the point. So we will be working here with pointers so that we can create and establish links between the different nodes. And once we are establishing the nodes and creating the links to it, then it becomes a linear data structure, and something else can be seen in this image, like data flows from one node to the other and are linked with the pointers, right? So in simple words, a linked list consists of nodes where each node contains a data field and a reference link to the next node in the list, right? Okay, so let's move on to discuss the anatomy of linked list. So what happens here is that just imagine that each of the nodes are like containers having two placeholders or two parts. Okay, so what happens here is that one is the data part, another is the part that holds your address, the address to the next node, right? So once it is done, then automatically the link will be established, and you can go on with your linking, and it will form a linked list as a whole, right? So there are certain terminologies that you really need to take care. First thing is the nodes, right? So this one whole thing is known as the node, right? It's going to have two parts, the data part and the address part, right? So it is said here, each node contains a value and a link, which is generally a pointer or the reference to some other node, right? Which is the some other node? This is the some other node, right? So the node containing the data value A is pointing to the data value containing B, right? So moving on to next, it says that the last node contains a null link, right? So this this node having the data value D is the last node out here, and you can see very clearly that it is not pointing anywhere, right? It is just null, I would say, and it's not pointing to anywhere. So it is also said that it is containing a null link since it's not pointing to anywhere. So moving on to next point, the list may or may not have a header. Now you can see here that my list is another node, but we are not going to say node because you know why? It just has one value, and that is the address of the very first node of our linked list, right? So here our my list is the header, and it only stores the address of the very first node of the linked list, right? And no data value is stored in the header part. So that is the entire concept of a linked list in the very simple words. Moving on to next, there are certain important points about linked list that you really need to keep in mind while you're working with linked list. Now what happens here is that a node successor is the next node in the sequence, right? Now what is successor? If you are very familiar with maths and stuff, then you will be knowing that the number that comes after is known as successor, right? And the number that has already occurred is known as the predecessor. So that's the thing. And as it says that moving on to the previous image, like here, this particular node containing the data value as B is the successor of the node containing the data value A, right? Similarly, if we talk about this particular node containing the value as B, it has the predecessor of the node which is containing data value A. So that is the concept. Furthermore, what happens is that the last node has no successors. Why? Because it is already pointing to nothing. Like it has a null address, right? So that thing you have to understand. And similarly, the first node has no predecessor. Means there is no other value or there's no other node that is being containing a value or something like that. There is only one thing, that's a header, and that does not contain a value. You know that, right? So the next point says that a list length is the number of the elements in it, right? So what this means is that, say for example here, we are having 1, 2, 3, 4, right? So there are 4 nodes, and so we can say that the length of the linked list is 4. So that's the point. And then we have a list containing no element also exists. Now you must be wondering, like, what will happen if you created a node and it has no value in it? So in that case, it is known as empty list, because it is very much possible that you are having a linked list or maybe just a node and it has no value inside it. Okay, it's possible. But in that case, it will be called an empty list. Further, a linked list is a dynamic structure. Now, what do you actually understand by the dynamic structure? We'll just understand in the next slide when we are discussing the difference between arrays and linked list, right? So as you can analyze that arrays and linked lists are two different data structures. Okay, even though they are pretty much similar, yet they have many dissimilarities also, or many differences also. Okay, so first thing is that the linked lists are more complex to code and manage than the arrays, but there are more distinctive advantages of using the linked list over arrays. Why I'm saying this is that because the linked lists are more like dynamic in nature, and the arrays are more like static. Why? Because just imagine you are declaring a particular array, okay, and once you're done with the declaration, then you store values into the array, right? And there's no scope of extending that array any further. But with linked list, no, it's not the fact. With linked list, what you can do is that you can keep on adding as many nodes as you want till the time you have sufficient memory. Till that time, you can go on adding as many nodes as you want to add, and this gives the linked list a dynamic nature, right? Further, it is easier to do the insertion and deletion operation in linked list, because what happens in linked list is that, like in linked list, you're not having this very discrete amount of space hold it up together, and it can how do I explain you, like if you want to insert any value, all you need to do is just create a node and put a link to it, right? And you can do the insertion very easily. You just have to change the pointers. But in case of arrays, irrespective of you're doing insertion or deletion, you also have to perform the shift operation, right? And trust me, the shift operation is really tedious and I really hate it. But I guess it would be happening with many of you also. So if you are having to do insertion and deletion at certain point, then please prefer linked list over arrays. But it obviously depends upon the question that you're solving. So that's an advantage of linked list over arrays. So furthermore, we have two more differences. The one says that both arrays and linked lists are linear collection of data elements. That's true. But unlike an array, a linked list does not store its node as consecutive memory locations, right? So what happens is that, like you have seen, right, that all your data values are being scattered in different memory locations, right? And the only way to access them is by establishing link to each and every node. Because just imagine, if you're not having a link, then that data value is going to get lost. You don't know in which memory location your value is stored, right? So you have to be very careful about your links, so that you can have the access every time you want it. You can keep a track of your values through the links only, right? And another point of difference between array and linked list is that, like, you must have this idea that while you're creating a array, what happens is that, like, you have indices. Okay, what indices are? They are basically specifying your position of the data value. Say for example, here the array index is starting from 0, then 1, 2, 3, 4, and so on, right? So basically what is happening is that you can track the value A, B, C, and so on by accessing this indexes only. Like say for example, if I'm saying array, what is a array value at index 4, then you would say that the answer is E, and that's true. But it's not the same with the linked list, right? There is no indices at all, and it is very difficult for you to access random values, and therefore you just have to follow your links so that you can access your values, right? So that is the difference between arrays and linked list. So moving on to next. Till here, if anybody has any doubt, please drop in the chat box so that I can solve your queries. Does anybody have any doubt till here? You can drop your questions in the chat box so that it gets answered. Nobody has any doubts? Wow, great. Then let's start with creating a linked list. Okay, so it is very simple to create a linked list, but it is a two-step procedure. Why two-step procedure? In the first step, what you need to do is create your node, okay? And in the second step, you have to establish the link between the nodes, right? So in C and C++, you can implement your very first node by writing this piece of code, right? What it is, let me explain you. There is a struct keyword, okay? And then node, which is a variable name, then int data, struct node asterisk next terminated with semicolon, braces close terminated with semicolon, right? Now, why are we using this struct keyword? So as to define the structure of the node, because you know that in a linked list, when we are creating a node, it has uh, two parts, right? One for the data, and the other one is for the link, right? So sorry for my handwriting. I'm just doing it with the mouse, so it's really difficult for me to do it. So yeah, the point is that it has two parts, right? And to create this two parts now, like, you basically have to tell the computer that hey, I want to create a node, I want to create a container which has two partitions, right? Like, it has two parts, one which is going to hold the data and the other one which is going to hold the address, right? So for that, inside this struct, we are going to define the, what to say, the structure, which says that there can be a variable of integer data type, meaning that whatever data value you're storing inside that node is of integer data type. And further, to create a node, what we are doing here is that we are creating a pointer. Okay, now this pointer is of the node type again, because the next node that will be created will obviously it be another node, right? So you have to define the structure. So that is the entire thing you need to keep in mind. So that's all about creating node. Now furthermore, why you need to create the next. Okay, now just keep your focus in the following lines. What it says is that the linked list provides an efficient way of storing related data and perform basic operations such as insertion, deletion, and updation of information at the cost of extra space required for storing address of the next node, right? So the fact that we are having this next is enabling us to do the insertion and deletion in a very efficient and smooth manner. So if you're talking about the array, that thing is not possible. It is a static data structure again. So to give dynamic nature to the linked list, we are basically having this pointer which is going to point to the next node and give you a dynamic data structure, so that you can keep on storing your values. Or even if you want to delete something, say for example, if you want to delete your node and you feel like it's not really worth it, so you can do that as well very easily. Okay, so moving on to next, memory management and linked list. See, memory management is very important aspect of linked list. Okay, because since you are going to have a dynamic data structure, so you have to manage the data so that it does not get wasted, right? Now I'll tell you why and how it is happening. Like, if you're very familiar with the architecture of the computer, then you might be knowing that there is a free pool of memory, right? So what happens there is that, like, whatever amount of free space that you're having in your computer memory, there's basically a structure holding all the free spaces and creating a free pool of it, right? So every time that you're declaring a node, as soon as you are saying the computer that, hey, I want to create a linked list and I need space for it, right? So every time the instruction is processed, and there is a pointer known as the avail pointer. So what the avail pointer will be doing is that it will be decremented by 1 and allocate that memory space to the node that you have created. Okay, so that is how it works. And once the memory is allocated to your node, then you can go on creating more nodes by checking if there is a memory space available or not. Once the memory is allocated, then you can go on creating more and more nodes, and then finally creating the link between them, right? So that's the thing. But you need to keep in mind that once you're deleting a particular node, that that whatever space was required by that particular node now, that node, since it is not existing right now at this particular moment, it has to be like recycled, yes, so that you do not waste up your memory. So there is a very important concept known as the garbage collection process. What happens here is that just focus on these lines. It says as when you delete a node from the linked list, the operating system adds the free memory to the free pool. Yes, exactly. That's what is happening. Like, you are deleting, like, just imagine you are emptying a particular pen, okay, and then what do? You don't throw away the pen, right? Instead you change the refill, so something like that. So next point says that the operating system will perform this operation whenever it finds the CPU idle or whenever the programs are falling short of of memory. So, like, to execute your program also, now you have to have sufficient amount of memory. Now let's say you are using up all your memory, maybe you are having heavy softwares or something like that. So in that case, you have to be very specific about your memory management. And what the operating system does is that it scans through all the memory cells and marks the cells that are being used by uh, some or other program. Then it collects all those cells which are not being used and adds their address to the free pool so that it can be reused by the programs, right? So this process is only known as the garbage collection process, and it is fairly transparent to the programmer because you have to have the idea. Like, you cannot just go and simply declare a array, or you cannot simply go and declare a linked list and say that okay fine, download program needs this amount of space. Just imagine there are certain cases in which your program does not get executed only because there is a wrong memory management. So you have to get this thing clear. Okay, so moving on to next, we have types of linked list. Up to here, do you have any question? If so, please drop down in the chat box so that we can have a review on that as well. May I have your questions, please, if any? Excuse me. Okay, so great. If you don't have any questions, then we can go on. Now, the fact that, maybe I'm not solving some of the questions for you is that this is just the introductory session, I would say. And, we'll be having subsequent sessions on linked list because for this linked list, there are also sessions where you will be actually solving programs and you will be having a practical understanding of the same. But to do so, you have to have the basic understanding of the entire concept, right? So that's why I'm trying to explain you as much as is possible. Just give me a moment. Okay, yeah. So moving on to next, we have types of linked list. There are three types of linked list that we'll be talking about. First one is the singly linked list. Second is the doubly linked list, and third is the circular linked list. Okay. So let us understand what each of this is. Like first off, we have the singly linked list. Okay, so in singly linked list, what happens is that each node contains a value and a link to its successor. Like we were indicating the idea of singly linked list only. Like I have been saying that there are going to be two parts that is going to contain the data value and the address or the link to the next node and stuff. So it was basically keeping in mind the idea of the singly linked list, right? So in singly linked list only you have two parts, and in doubly linked list and in other types of linked lists the structure is a little bit different. Okay, so what happens here is that the header points to the first node in the linked list, and it contains a null link if the list is empty, right? So this is something we have talked about and we know also. And important thing that we need to keep in mind is its structure. Obviously, just have a look at the structure so that you get it really clearly. And also we refer to singly linked list as SLL. So moving on, next we have the doubly linked list. So in doubly linked list, what happens is that like it has two pointers instead of one pointer and one data value. So here this is also one pointer and this is also another pointer. Okay, this one is known as the previous and this one is known as the next. Okay, so what happens here is that like considering this particular node only, we can see that the next of this node is pointing to the node having data value as 3, and the previous of this node is pointing to 1. So that is the concept of doubly linked list. We'll see how you are creating the node structure of a doubly linked list, right? So moving on to next, creating a doubly linked list. In C or C++, the structure of the doubly linked list can be given as follows. Like it is pretty much similar to that of the singly linked list. Okay, but there is a slight difference is that you are going to have two pointers, one here as the previous pointer and the second one as the next pointer, right? Now the previous field of the first node and the next field of the last node will contain null, obviously, because they do not indicate any address, so it has to have the value null, right? So see the syntax so that whenever you're working on with the practical problems, then you're not going to mess up with the syntax, because many a time it happens that we understand the concept but we mess up with our syntax, and then we get errors and we don't want to do this thing, right? So keep in mind the syntax. And then moving on to next, again we'll be talking about the memory management of doubly linked list. So what happens here is that the memory management is more or less similar only, but say for example we want to store a value hello, right? So there are 6 letters in this word. So the very first letter is H, right? So the data we have is H, and where is it pointing to? -1. Now what is this -1? This -1 basically indicates null. Okay, so that is something you need to know. Like if you're having this -1 or X representation, this is something saying that it contains a null value. Okay, so that is the thing. And for the next pointer, it says that it is having value 3. So where is the 3? This is the 3 out here, and it has a data value that is E, right? So after, like if you're considering the word hello, the next letter is obviously E, so it is found in the location 3, and so on, right? But as stated that the last node is obviously going to have null value, so you can see that it is again containing the value -1, right? The O is having the next pointer as null. So moving on to next, we have the circular linked list. Now circular linked list is almost similar to your single linked list only, but there is a exception that you need to note is that, like, when you're considering this particular diagram, up till here it is the same thing only, right? But this pointer, the last thing, which is generally null, is actually having now the value of the address of data containing one, right? So that's the issue. Like, now it is establishing a link to the very first node, which is containing the data value as one. So this gives a what to say, sorry, last node will never point to null, it will again point. Yeah, exactly. So that is the thing. Like, it will point to the first node, and that gives it a circular structure, I would say. And obviously you can abbreviate it as CLL, right? So that is the understanding of circular linked list. Moving on to next, if you want to focus on the memory representation of circular linked list, like in the earlier one, when we were dealing with your doubly linked list, you saw that it was having the value -1, right? But now it's not having -1, rather it's having 1. Now what 1 holds is the H, right? So it is basically cycling the entire value over and over again and giving you the same result, right? So that was it. Now, finally, we have the operations in linked list. So, as stated, the linked list is a data structure which facilitates you for easy insertion and deletion. Other than that, there is also, two more operation. One is traversing, and the other one is searching, right? So I will start with this topic, but before that, I just want you guys to have a short break so that you guys can analyze upon whatever I say till this far, so that you can proceed further, because in coming up time I'll be discussing the algorithm a little bit so that you can grasp it very well. Is that fine? You can drop your thoughts in this chat box. Perfect. So we'll be going on for for a break of 5 to 10 minutes, and then we'll be resuming. Okay. Okay, so let's resume so that we can complete everything, right? I hope you all are here already here on the meet, right? So moving on to next, we have the operations in linked list. As I said in just 2 minutes earlier, that we have this traversing, searching, insertion, and deletion. So let's look into the algorithm so that you can understand how to create your very first traversing program in a singly linked list, right? So there are 5 steps if we are talking about the algorithm. Like if you want, you can click a snapshot of this entire algorithm so that it will be easier for you to, refer to it every time you're doing your programming and stuff. Okay, so let's begin. Step 1 says that initialize, right? So how are we going to actually initialize? Like as we know that there will be a pointer, right? First of all, we have to declare our pointer, and then okay, no problem. Yeah, sure. We can share the PPT so that you can refer to it. Definitely. Yeah. So after you have initialized all your values and you have created your node, right? What you need to do is that you need to initialize your pointer with start. Means you have to have a pointer which understands that okay, this is the very first value and I need to keep track of the address of the very first node, right? So moving on to second step, it says that repeat step 3 and 4 while ptr is not equals to null. What is ptr? Ptr is the pointer that we have taken and is now pointing to start, right? So here is our very first node and the head or the pointer is showing us the address of the very first node. Yeah, exactly, the reference pointer. And then what will happen is that like we will be setting up a while loop. While loop will say that until and unless you reach the end of the list, right, till then you have to keep on traversing, like you have to keep on looping around and visiting each of these nodes, right? Now step 3 says that you have to process PTR data. Now what this means is that processing the data value means to print it out, right? Now say for example the obvious result of this linked list is ABCD, right? So how will it happen? It's not going to happen in one go. You have to apply a loop, right? Once you're applying the loop, then you get it printed, right? So after your loop is like while you're executing your loop, it has to keep on going to the next node, right? But how will you make your computer understand that it has to go farther, right? So you have to change or increment, you can say, your PTR value to the next, right? Now your head is, yeah, exactly. So now your head is pointing to the very first a very first node of your linked list, and it already has the address of the next node, right? So what it will be doing is that it will erase this and then it will point to this, and then it will execute the value of B, and then it will go on till it reaches null, right? So then we will encounter the end of the loop, and once it is done, you will get the printing as A, B, C, sorry, D, right? So you'll get the value as ABCD and then exit, right? So that is the entire algorithm of traversing in a singly linked list. It is more or less similar for doubly linked list also, but you just have to keep in mind that the doubly linked list has 2 pointers, so you can basically go like forward also and move backward also, right? So that is the thing. And in circular linked list, what you have to do is that once you reach the end, then you can move to the front again. So basically you are moving in a circular fashion. Now moving on to next, we have searching a singly linked list, right? So just have a look at the diagram so that you understand what I'm trying to say. Because like say for example you are having a linked list as this one, okay? It has different values like 1, 7, 3, 4 and so on, right? But you want to find out a specific value. Now how will you find that specific value? Like you have to make your computer understand that thing, right? So to do that, you will have to store your value in a particular variable, and then examine that value with each and every data value that is present in the linked list. Once the match is found, then automatically what will happen is that the loop will be stopped. Once the loop is stopped, the position is printed, and it will show the result that it is being display, like it is being found, and once it is found, you are done with your work, right? So that is the entire concept of searching. Now have a look at the algorithm. First, obviously, you will set the ptr to start. That's the very first node. And then step 2 says that repeat step 3 while your pointer is not equal to null. Means till your list is not ended, till then you have to keep your loop on, and it has to keep on searching and searching and searching, right? Now, if in case your value is equals to print data, ptr data, then the match is found, right? And in that case, whatever position your data value is encountered, you will say that the position is equals to the ptr value. Means, say for example, if you're finding your data value at 1 2 3 third position, then you will say that considering this to be 0, so you will say that I found my data value in the third index, or maybe in the fourth position, like that you can say, right? So if your value is found out, you can obviously print it and you're good to go. But if it is not so, then you have to increment or move farther, right? So you will have to execute this particular line which says that your ptr is going to point to the next value, right? And it has to keep on going. So this entire loop keeps on going and going till your value is reached. And once your value is reached, you will come out of the loop and go to step 5. But in case if your value is not in the list, what will you do? You'll say that the value is not found, and you'll set position equals to null. That means that your value is not found in the list, right? So that is the entire concept of searching a value in the single linked list. Moving on to next, we have insertion in linked list and deletion in linked list. Okay, now when we are talking about insertion, then there are 4 cases, as you can see, in insertion of linked list, and also for deletion of linked list also there are 3 cases. Okay, so now I won't be going and explaining you the algorithm of each of these 4 cases. I guess there would be a subsequent session where you will be understanding this algorithms of insertion and deletion, and furthermore you will be obviously solving some problems so that you can have a clearer idea. So that was it. If you want to refer, obviously the ppt will be provided, so have a look at the 4 different cases of insertion in linked list. Like the first one says that a node being inserted at the beginning, then second one says that insertion at the end, then third one says that a new node is inserted after a given node, then fourth case says that insertion before a given node, right? So accordingly, the algorithm of each of these 4 cases are different, and you have to keep a real good check over all those things. And last, we have the deletion in linked list. There also we have 3 cases. Like, you have to know the algorithm for removing the very first node from a linked list, and then deleting the last node from the linked list. Like, deleting the last node in the linked list is really very easy. It's just that you have to set n-1 node to null value, and then you are actually decrementing 1 node, and that deletion is done basically. So you just have to change the pointer. Yeah, exactly. So third case that we have is deleting the node after a given node in a linked list. So that has a separate algorithm. And we are approaching towards the end of this session today. And this is something you can read out if you want. There where your linked list is basically used. It is obviously used to implement the stakes and queues. It is used for implementing graphs. Then it is used to implement your hash tables. So you know what? The point why I'm discussing this thing is that you will understand the importance of linked list, because many a times people think that okay fine, linked list is not really used as much as array or other data structure is used or something like that. So that in order to have a better understanding of these things, you can refer to the applications of linked list. And so this is the end of the session, and I shall take leave. Now, I hope you understood whatever I tried to communicate with you. So, but it's used in computer. Yeah, exactly. That's why I was saying, like, you generally would think that it is not going to be used much, so I gave you the applications of linked list also, so that you get a reason to learn linked list. Obviously it's not much used in competitive programming, as somebody said. Yeah, so that's all for this session. Thank you so much for joining, and I shall pass it on to the Geeks for Geeks people. Thank you so much for giving me the opportunity to speak, and that's all. Thank you so much. So bye bye. I will be closing the presentation now. If you have any queries, you can drop your queries down, and then we can discuss. Yeah. Thank you so much.